Hey, okay, so example 4B. So example 4B is going to be some problems that you're very likely to see on the AP exam. This is a very popular situation. And here's the thing, they're wanting you to find a value of k that would make the function continuous. Well, here is the function whenever x is less than or equal to 2. And this is the function whenever x is greater than 2. So this would involve the limit from the left. And we want the limit from the left and the limit to the right to equal the same thing, but they're both going to be a direct substitution. All right, so I don't know. So it seems like a little overkill here, but I'll write out what I just said. So the limit as x approaches 2 from the left of g of x is using this top function, because that's what it means when you're coming from the left, you're less than 2. So I just simply make 2 my x. So that'd be 2 squared, so that'd be 4k. All right, and then likewise, and this is kind of showing a whole lot of work here, but I think you could probably do it quicker. But I'll show everything. All right, so coming from the right then of g of x would be substituting 2 into the function that you're supposed to use to the right of 2, which is this one down here. So x then is 2, because that's our boundary, and so I'll have 2k minus 6. All right, so they're the two limits from the left and the right, and so now I want to make sure that they're equal to each other. So the limit then, as x approaches 2, would be when those two are equal to each other. So I would go 4k is equal to 2k minus 6, and just solve that. All right, so subtracting 2k from both sides, 2k is negative 6. K is negative 3. I mean, sorry, this is k. Okay, here we go. Yeah. K. All right, and then k is negative 3. Now, this is the answer. But if you wanted a little justification, then you could just substitute in and show that indeed they're going to both be the same value. So up here, as you're approaching 2, if k is negative 3, then that's going to be negative 3 times 2 squared, negative 3 times 4, negative 12. And then here, if you put negative 3 in here, you also get negative 12, because that's going to be negative 6 minus 6. So they're both equal to negative 12, but it just said find the k, and that's what I did. All right, now on B, all right, this one's interesting because, all right, as I'm approaching 4, I know this is less than 4 and all that, but as I'm approaching 4, this is going to be something over itself. Now, of course, if I'm approaching from the left, sorry. So if I'm approaching from the left, it'd be something over its opposite, because like if I tried 3.9, 3.9 minus 4 is going to be a negative, but I'm about to make that absolute value. But on the bottom, it'd still be negative. So, but they would be opposites of each other. All right, so let me write that down instead of rambling. So the limit as x approaches 4 from the left. Now this is from the left. Those two are going to be opposites of each other as I do that. So, and this is h of x. So that's going to equal negative 1. All right, so then I just need to make sure that the limit as I approach x approaches 4 from the right is also equal to negative 1. We'll do that in a second. So the limit x approaches 4 from the right of h of x is using this bottom one, because that's the greater than 4, and that's what's happening when you're approaching 4 from the right. But we can go ahead and substitute 4 in for x. And so that would be 5k minus 16, because you're substituting 4 in for x. That's how you evaluate that. All right, and so then we want these to equal to each other. All right, if you need a little more talk about this negative 1, hopefully I kind of went through that kind of fast, but hopefully that makes sense to you. I mean, this thing would be exactly the same if they're both positive, but they're only going to be positive when you're bigger than 4. So when you're less than 4, they're opposite of each other. That one's positive, that one's negative. All right, hopefully you got that. All right, so now we're just solving this equation. Ooh, gross, really? All right, so adding 16 to -1. Oh, it's not too bad. So that would be 15. Is the same as 5K. Okay, K is 3. So really, the K being 3 is just going to make that right-hand limit equal to -1. That's all we really cared about. And that's right here. So if I substitute 3 right there, I got 15 minus 16, which is -1, therefore matching the left-hand side. Okay. All right. Kind of a tricky one there, but definitely doable. Example 4A.